Imagine a world where tiny bits of sand are transformed into the most powerful machines on the planet. Sounds crazy, right? Well, that's exactly what happens when we turn quartz into silicon chips. The brain of every computer. These chips start as raw materials dug from the earth, then go through a process of refinement and engineering magic to become the processors that power your phones, laptop, and even supercomputers. But in order to compute, you need PU, right? A processing unit. So which type of PU does what? That question arises very quickly. Let's break down the different types of processing units, starting with the CPU. The brain of the operation. At the core of every computer is a CPU, Central Processing Unit. Think of it as the brain of the computer. It makes complex decisions, processes instructions, and keeps everything running smoothly. The CPU's job is to execute programs like opening your browser or running a game, handle calculations so your apps work correctly, manage memory and data flow so your computer doesn't crash. The first commercial CPU was an Intel 4004 microprocessor, which was a 4-bit processor, meaning it could process 4 bits at a time with 740 kHz clock speed. That was very fast at its time. But nowadays, modern CPUs are far faster and powerful, running at gigahertz, which means billions of cycles per second that I can't even comprehend.
1 billion, gajillion, fifillion, million.
And also based on not 4-bit but 64-bit processing. And if you compare the old Intel one with an AMD 9800 X3D, the best gaming chip on the market right now, then it will be a million times faster than the Intel one. That is... Anyway, in the old days, CPUs had a single core, but now modern CPUs have multiple cores that allow them to multitask. But adding more cores has its limitations. It increases heat and power consumption, which is why most high-end CPU max out around 24 cores, unless you're running a giant server farm where there can be an AMD Epic CPU with 196 cores that can cook your dinner if you want to. Depending on the device, CPUs come in different flavors like x86, ARM, and many others. But x86 and ARM are most popular ones. x86 is powering desktop, meanwhile ARM is found in phones and tablets. The reason behind this is that x86 doesn't have a power limit and can push the performance with the power and cooling. It is more complex and inefficient to run on mobile devices because mobile devices need to be performant but with a great battery life. So your Nokia can stay on without 1 day of charge. But this scenario has been changing thanks to Apple's own developed M series chips that are based on ARM architecture while giving good performance with much more efficiency. That's why other manufacturers are making ARM chips like Snapdragon, and AMD and NVIDIA are also planning to make ARM chips. I don't know what Intel is doing, or they are still in business at your watching because they are in very bad situation right now. Though things can change because nobody knows the future except those guys behind the process of making fortune cookies. They can guess anything. I just don't know how do they guess. By the way, I don't know why I make this chart because I made this chart, so you have to watch it for 5 seconds to appreciate the time I went through making this one. And now here it is the GPU, the graphics power. If the CPU is the brain, the GPU, graphics processing unit, is the muscle. Originally designed for rendering graphics, GPUs are now used much more than just gaming. Unlike CPUs, which have few powerful cores, GPUs have thousands of smaller cores, allowing them to render video game graphics in real time, train AI models, which is why companies like NVIDIA are now AI giants, handle massive calculation in science and medicine. But here's the catch. There is a catch. A CPU core is way smarter than a GPU core. CPUs handles complex logic and decision making, while GPUs crunch numbers at high speeds in parallel. That's why we need both. They specialize in different things. GPU was built for graphics, but not for AI, which is what Google realized and made the TPU, built for AI. In early 2015, Google developed the first TPU in their servers and took things a step further in the AI market. AI! Which improved their stock price dramatically. They are faster than GPUs at AI tasks because they handle matrix multiplication very easily, a key part of how neural networks learn. If you're training a massive AI model that takes weeks to process, a TPU can cut that time at half, saving millions in computing costs. AI companies love them. Regular people, you probably won't need one yet. DPUs, the data reuse of the operation. Now, let's talk about DPUs, data processing units, the unsung heroes of cloud computing. If CPUs are for processing tasks and doing system stuff, and GPUs are for graphics, DPUs specialize in moving data around massive networks. They handle networking tasks like managing internet traffic, security and encryption, keeping cloud data safe, data storage and compression, making sure giant servers run efficiently. You won't find a DPU in your laptop, but if you have ever streamed a movie or used cloud storage, you have benefited from one. You may wonder if GPU is handling the graphics, making the hands free of CPU, and TPU is taking the tensor processing or AI handling, whatever you want to say. DPU is doing the data moving work, then what's the CPU is doing? Rather than just opening some apps, managing them and chilling at his free time. Where other PUs are likely swallowing tons of data and consume power like a microwave, a framework that NVIDIA is very known for. If you're thinking something like that, then you're right. You'll see that people saying all PUs must be utilized to closer or equal to 100%. But everybody will say that hitting 100% CPU is bad because it's what controls the whole system. So if it sees some stars at who will be crashing the processing game, then you will see something like this. Your PC getting crashed. Go out of your home and breathe some fresh air and never come on internet again. Now let's talk about the next PU, quantum processing unit. It is getting too much quantum. I still don't know if the cat is alive or not, but right now all computers rely on bits, tiny electrical signals that are either 1 or 0s. But quantum computers, they use qubits, which can be 1 or 0 or both at the same time. This is called superposition, and it's like being able to flip a coin and have it land on both heads and tails at the same time. Sounds cool, right? But I am too much stupid to understand this thing anyway. So why this matters? Because quantum computers could break modern encryption and say goodbye to online privacy, simulate molecules for new drugs, revolutionizing medicine or something else also, solve problems in seconds that would take today's computers billions of years. Right now, quantum computers aren't practical, but if they ever become available and reliable, they will change everything. From CPUs and DPUs to TPUs and DPUs, every processing plays a unique role in making modern computing possible. And with the quantum computing on the horizon, we might be on the edge of a technological revolution, unlike anything we have seen before. So next time you use your computer, remember you're controlling a machine that started as a tiny grain of sand. Thanks for watching. By the way, I forgot to mention one thing, that